Let's look at some of the changes that have been added to the KNIME Analytics platform in the most recent version. The version 3.4 has been released on the 12th of July, along with some commercial components, which are not covered in this video. There's a long list of changes, like new nodes, enhancements, bug fixes, and if you wanted to know all the details, you would go to the KNIME webpage, and then you would find it on the What's New summary page or in the changelog. What we'd like to do in this video is to pick some of the highlights and present those. Let's start with the views. In KNIME you have many views, and a subset of those are available as JavaScript views. There are 3 new views available in version 3.4, and they are listed here. And instead of describing what they actually do, I'd like to give a short demo. Here we are in KNIME. We are reading a data set, which is the Titanic data set. So passengers traveling with the Titanic, described by their gender, age, which class they traveled, if they were with family, what ticket fare they paid, etc. And then also if they have survived the disaster or not. So we'll do some pre-processing of the data and then go into this, what's called here the wrap metanode. So I can enter this one. And in here, I find the new JavaScript Sunburst chart, which is displaying the group data. So I'm going to open this one, the view here. And this is a Sunburst chart. It allows me to show groups in my data set. Each of these circles represents one attribute or one column. Like for instance, the class, first class passengers, second and third class. The second ring is then the gender, like male or female, then whether the passenger was traveling with kids, and in the outermost ring shows me how many passengers in those categories have survived or died. This view is very useful as it is, but it becomes really powerful once it's combined with other views. And this is done in the wrap metanode composite view. So I'm going out here and then I go to the composite view, which is also a new feature in version 3.4. And here I have again my data set along with a plain table, and these 2 views now talk to each other. So again I can still go and drill down into my data set, but I can also make them talk to each other by going to the selection mode, and then, for instance, finding all the passengers that have those certain attributes here, like all the first class passengers being female. Can also do some filtering here in the table view to have a filtered down data set, and then I can explore my data further and then, for instance, go down into those segments and then better understand how this splits up. And then I see, for instance, first class passengers, female, traveling with no kids, had a fairly high chance to survive the disaster. This is useful. There's also another short demo that I'd like to show here. We are changing the data set. This is now some chemistry data processed with one of the KNIME community extensions. So here we have some chemistry data and some descriptors. And if you come from that domain, then you know how to process those, but let's not care about that for the moment. Here we have some wrap metanode that allows us to display the data again in a plain table along with some parallel coordinates. That is a different type of visualization of the data set. I have filters in here that allow me to filter my data set down, etc. I have the usual selection and highlighting, which is nice and useful. One of the new views that we added is a network viewer. So what this workflow does, it takes all these structures and builds some network out of it, where different components are connected when they have, let's say, when they have a similar hub score or if they are similar authoritative. So let's quickly peek into the wrap metanode view. So again, we have some range sliders, and then we have different visualizers like this new JavaScript network viewer and just a plain table. Again, if I use the wrap metanode view, and look at it, then I see my slider definition, the table, and then the network itself. So each of these nodes in the network represents one structure, and there's a certain way to connect these different structures. Okay, so this looks quite busy here, but there's also a filter, and I can do some filtering, and that immediately removes quite a portion from my data set. So this looks nice here, and now I can also go and do some selection events here and see, for instance, the points that are selected here on the left hand side. The network view then has tons of options that you can set, one of which is the network layout, so I can choose different layouts here. And then, for instance, if I choose concentric, oops, there's one that seems to be interesting and highly connected to all the others, so I can do further investigation of that component here. Another new feature of the version 3.4 is the KNIME Personal Productivity extension, which is now free and open source and pre-installed. What is it? It's a set of useful tools that allows you to be more efficient designing workflows. There is, for instance, the workflow div. The workflow div allows you to select two different workflows and compare them to each other. So you would see which nodes have been added, which nodes were removed, and for which nodes has the configuration changed. This is how it looks like. So you have all the nodes and you will see the differences here. Metanode templating allows you to design metanodes and share it with yourself by putting them into the KNIME Explorer. So you would save a metanode into the KNIME Explorer, and then you can use that same metanode and put it back into the same workflow or a different workflow. And changes to the template will be reflected in all the instances. Another feature is the call local workflow node that allows you to call out to other workflows in your workflow repository. These workflows can then be parameterized, like shown here on the right hand side, and it allows you to orchestrate all your workflows and keeping these workflows simpler, but instead spreading all the complexity across different workflows. Let's do a short demo of these of some of these productivity extensions. So let's go back to the workflow that we've seen previously, where we have all these wrap metanode views. Before I go into the personal productivity extension, let's quickly look at the workflow as it lives here. If I now right click this one, there's now also a new option that's called deploy to server. So I could go here and say, for instance, I put it onto the KNIME server, and this will then be immediately uploaded to the KNIME server and also selected here. This is now a workflow that lives on the server. I can also choose this one here, and on the server I have a new option, open in web portal, and this will open the workflow on the web portal, and then I can immediately start using that workflow, and this will take me through all the views that we have seen and defined previously in the demo. We have all the selection, etc. This one would then go further, and then I have all my my calculation done, and this will essentially take me through all the steps that are defined in the workflow. Going back into KNIME, and let's talk about personal productivity extensions. Let's start with the metanode handling here. Metanode handling means I can take any of the wrap metanodes, right click it, and say, for instance, save as template, and then I can choose where to save them. Let's just save it next to the workflow. And then I can also link it. So this metanode is now linked with this particular wrap metanode template, and this I can also choose and drag it into the same or a different workflow, and I can just reuse the function that I have defined in that wrap metanode. The workflow div, let's talk about the workflow div. This is now the typical situation where you have your workflow and you want to make modifications to your workflow. Let's say, for instance, you make some config changes to the reader node, or you add a new node to your workflow. So you make some modifications, and then you do not want to overwrite your existing workflow, but instead save it as a new version. So you save it to a new version. Now I ended up with 2 different versions, possibly more, but I lost overview of what has actually changed. So I can now, using workflow div, select the 2 workflows, right click, and then say compare. This will bring up this view after analyzing the workflows. And here now I see all these nodes. I can hide all the ones that are identical. And now it would tell me there is, in this new instance, there is a new node, the column filter, and for the table reader where it found a match, there's a change in the configuration, and now I can also drill down and see what has actually changed. So for instance here, that particular configuration parameter is now different. There's a bit more, but this is beyond this little video. Also in 3.4 we now have an integration with H2O. H2O is a fairly popular open source machine learning framework that has a strong focus on providing very fast and scalable implementations of state-of-the-art machine learning algorithms such as boosted trees, random forest, linear models, etc. Their focus is extremely on making those algorithms efficient and scalable. By that they also provide different modes of execution, whereby you can run local execution or also run this distributed backed by Hadoop or Spark. The integration in KNIME looks like like shown here. So you have a bunch of new nodes that you find in KNIME Labs that allow you to convert KNIME tables into the H2O frame, and then you can apply all the various algorithms on those frames. We currently only support the local execution. We have the quite a number of learning algorithms integrated, and also support the various scoring measures like extracting confusion metrics and all these statistics that you would expect. Let's go to a quick demo. So here we have our KNIME workflow. First of all, the H2O category is, as I said, in the KNIME Labs category, and then you find all these different utility nodes, but then also the different models for generalized linear models, boosted trees, naive Bayes, random forest, etc. And then also various scoring nodes. So what does that workflow do? First of all, it starts off reading the dataset. In this case, that's again the Titanic dataset, where given different attributes of the passengers of the Titanic, and the task is to predict what survived the Titanic disaster. The workflow first takes that table and converts it into an H2O frame, and this is done by providing a context. At this point, this is a local context, so it runs in the same JVM, and the output, this yellowish output, is now H2O frame. I can also look at the output, and then we'll see again my table, but it's not a KNIME table but an H2O frame. And now I can use some of the pre-processing nodes like partitioning, and then feed this through the various learners. So looking here, for instance, at the GLM learner, if I now open the configuration dialog and then go through the algorithm settings and advanced settings, you see how many settings there are. So there's all these nodes have quite complex configuration settings. So a model is learned, which then produces this orange port, which is a predictive model, and then I can use that predictive model also in the classification node. That looks more familiar to all the other KNIME predictor nodes. And then I can also do some scoring, whereby in the scorer you have to provide the true attribute and the likelihood or the prediction column, the score of the prediction. The reason is that H2O computes all sorts of other measures like area under the curve and other measures that need to be derived from scores rather than just crisp predictions. In KNIME you can then obviously also use all these loops, like for instance a native KNIME node which is called parameter optimization loop start, which allows you to set different configuration parameters, and then you can scan through these configuration parameters and determine the best configuration. And the output here is then for each of these configuration settings the different scores. The last feature we'd like to present is an extension for processing audio files in KNIME. In order to do so, we have introduced a new cell type representing audio files, and then there is a number of new nodes that allow you to read in audio files, doing all sorts of feature extraction and then also speech recognition either offline or by using external services. Let's do a quick demo. So here we are in KNIME again. The new nodes all hide currently under KNIME Labs. There's a new category IO, and that has all these new nodes for reading, processing and transcribing audio files. Here's a typical use case. So we are using one of those list audio files pointed to a bunch of WAV files. These WAV files are recordings of some of our native speakers reading a sentence. So let's hear that.
Welcome to Berlin. Enjoy the summit.
Welcome to Berlin and enjoy the summit.
So these are the files that the file reader then reads, and then we can just point these files and take these files and process them by, for instance, an offline speech recognizer called CMU Sphinx, or by using external services, namely IBM Watson speech recognition and Bing speech recognition. So the config dialogues here look fairly typical. And then for the external services, you also have to provide API keys in order to use those services. Furthermore, we can also run some of these data extractor and feature extractor nodes that then allow you to, for instance, extract very simple properties from the audio files, and that can then be visualized just in a plain table. So let's see what these services have transcribed. So here are our audio files, and then this is the text that has been detected by then either CMU Sphinx, IBM Watson, or Bing speech recognition. Some of those are actually correct. For these online services, you also get some score, how certain the service was to have detected the text correctly. Here we have our properties, and this can then be used either, also on larger data sets. So much on the audio processing. Going back into the slides, a few more words on other changes that we haven't prepared a demo for. Also new in KNIME 3.4 is two new cloud connectors, namely for Amazon Redshift and Amazon Athena. Amazon Redshift is a highly scalable data warehouse, and the integration into KNIME is just by means of having an Amazon Redshift connector node that then behaves like, let's say, any other average database connector node. And Amazon Athena is a fairly new, hip technology, also available as an AWS service that mimics a database on top of a bunch of files that live in Amazon S3. Also, this connector is just available as a database connector node, and then you can use the breadth of all the different database utility nodes that you find in KNIME to do further processing of your SQL statement. And then once you run those statements, the actual computation happens on the remote side. That means in Amazon Athena or on Amazon Redshift. Also in 3.4 we have revised completely our date and time integration. That was quite a lot of work, and the output is here shown on the right hand side. There are a number of nodes that allow you to read in date and time, pass date and time, shift date and time zones into your local time zone, convert durations, etc. So starting with one single cell representation for date and time, there are now in total 5 different data types for all sorts of granularities of date and time. Another new change is the Python 3 support. So we have a new Python category in KNIME Labs that is based on a different framework for integrating with Python. This has a significant speed up over the old Python integration that you found previously in KNIME, and big benefit here is that it now also allows you to use Python 3 scripts. You can, in the config dialogues of all these nodes, you can switch between either using Python 2 or Python 3, and which Python executable it uses is then defined by means of a preference page. Two more changes. The logistic regression node has been rewritten. We have added a few more solvers that solve the optimization problems. One of which is called SAG, Stochastic Average Gradient, and this is much more performant compared to the old implementation, also for very large data sets or very wide data sets. Also, the logistic regression node now has an additional output that contains the coefficients that the logistic regression node calculates. On the deep learning front, we have upgraded the deep learning for J version, and this now comes also with a very powerful word-to-vec model support that, for instance, also allows you to read external word-to-vec models if you wanted to do text processing by using, for instance, word vector models that have been trained, for instance, by Google, etc. So much on this. Thanks for your attention and enjoy.